Good morning, everyone. Welcome to the final morning of the FloCon conference. This morning, our first session is going to be on C&D strategy and modeling, and we have a number of really good speakers. And you all should be experts on that by the end, and if you're not, you can email me at jspring@cert.org to complain. I'd be happy to hear everything you have to say. So our first speaker this morning will be Tim Shimeall, and he has a very fancy title as the Senior Network Situational Awareness Analyst of the CERT program at the Software Engineering Institute. But probably the most notable accomplishment that he's made out of all the many accomplishments that he has done is that he has been to 11 consecutive FloCon conferences. And so he is the record holder, and if you get a chance, you should congratulate him. So, Tim Shimeall.
Good morning. Welcome to the last day, the few, the proud, the Thursday folk. And we, CMU also insists that we put up the legalese. Here it is. What we're going to be talking about today is defensive security strategy, and particularly the role that Flo can play working on a series of different strategies against malefactors, malicious actors. And the idea is to have analytics supporting several orthogonal approaches to defending your network. The particular orthogonal approaches that we're going to look at are deception, frustration, resistance, and recognition recovery. And I'll close off with a brief recapitulation, just so that we've got an end to the talk. And in keeping with the approach taken in this talk, I'm going to plug a book. This one's not Mike Collins' book. This one's from Jono and I. It's an information security textbook built around introducing information security in terms of these security strategies. And so I copied the outline from the book, or at least the flow of strategies, and built this talk kind of around it. So the first of the strategy is deception. And the idea of deception is if you're going to fight, do it on somebody else's turf. And so you want to encourage the attacker to go someplace else. And one of the ways to interpret it is kind of point them off to somewhere else. If you can't force them onto somebody else's network, at least force them onto a host you don't care about or care less about. And then the issue becomes, okay, we've got these deceptive hosts on our network. How do we make sure that they act like production hosts? Well, that depends on knowing what production hosts do. And that leads to an understanding of the traffic baselines. And it turns out network flow analysis has some pretty well-established state-of-the-art for generating traffic baselines and for understanding the traffic baselines. George Jones and Austin did a tutorial at FloCon 2012 on that subject of establishing the traffic baselines and doing that network traffic analysis. The other issue is making sure that the deceptive hosts and the production hosts at least seem to contact many of the same external parties, so they're acting like it that way. And that involves coming up with context sets. And this is not terribly difficult science in terms of network flow analysis. The basic idea here is you build up IP sets, incoming and outgoing over time, per interesting hosts. And here's a profile of one set of doing it. I took the blue-red data set because that way I could get the presentation approved to present to you folks. The blue-red data set is a capture the flag exercise run in 2009, and it ran over 5 days, and so the 5 days are basically the 5 lines you see there. It is an aspect. Well, this is not showing up very well. So let's see if I can get the cursor to show up. It's not. Okay, you see the 5 vertical lines. The green hosts are the incoming connections. The red hosts are the outgoing connections. They're displayed over basically the same IP space, which was all 10 dot addresses for the exercise. And it basically allows you to do a graph. In this particular case, the incoming and outgoing graphs are relatively similar. So you've got some fairly easy profile that you could automate and duplicate. In other cases, the incoming outgoing graphs are going to be more difficult, so you're going to have some scripting to make sure that they contact in similar ways. Beyond contact sets, there's the idea of contact patterns. Contact patterns are basically looking to see if you can develop a profile of how much they send data over which protocols. And the whole idea there is basically, yes, I want to make my deception hosts act as much as possible like my production hosts without actually parking users at them or anything like that. So there's a lot of scripting that's going to go on. Scripting that looks maybe a little bit like that. This is a skeleton script for doing contact set generation. And yes, it's using the Silk tool suite because I do work for CERT. And the bright blue parts are basically parameters or things that you would parameterize. But rather than using shell scripting like $1, $2, $3, I figured it was smarter just to give you some name to hang it by. I'm assuming that you can come up with your own selection parameters as to what date and network is of interest. Looking at allowing for an ignore set so that there's interactions you don't want included in your contact sets, and a given level of threshold so that there's a certain amount of data for actually qualifying to being in the contact set, and then building the active set, and then going through the active set essentially host by host and building off the contacts over a given day and coming up with basically the input to a plot, although it could also be the input to a traffic generation routine coming out of the bottom of it. So that's one option. You've got flow analysis, you've got analytics that basically can help inform the types of activities you might want to do for network deception, particularly for host-based network deception. There's certainly types of deception that would not be well supported by hosts. For example, data-based network deception, where you're coming up with false content in hopes that the attacker will get distracted and go after the false content rather than the real content. But in terms of network behavior, Flow seems to provide a useful information base. The second strategy is frustration. And the idea of frustration is if we cannot get them to attack things that we don't care about, either because they're somewhere else or there's not much value there, we can at least make it hard for them to initially get into the network. And this basically devolves rather rapidly down into, well, where are they likely to attack? Well, where they're likely to attack are services that we are likely to provide, and that moves into the attack surface that might be present for the network. There have been a series of presentations about the attack surface, in particular John McHugh, back in the day, did a number of different presentations at FloCon on attack surfaces. There's been some further work on attack surfaces done at CMU. But the basic idea is you want to extract the common services that are accessed externally and provisioned internally by the network. And you want to be able to understand how much traffic is going over these services, and then the network blocks that typically serve as communication partners, and start to profile the activity and be able to spot deviations from that activity as a goal of trying to identify people that are initially trying to attack into the network. And the closer to real time you can do this, the more effective you can be at blocking frustration. So this could be something that you could build into some real-time estimation method. Probably not pipeline because it demands more memory than pipeline generally has available, but some similar mechanism of real-time alerting and building off of that. Beyond dealing with the attack surface, the question is, okay, within this attack surface, where are likely patterns of attack? And that gets the idea of where is my network actually vulnerable? And that looks, again, starting at common services, but you start looking at identifying traffic surface signatures for relevant vulnerabilities, and then applying those across the hosts to try and understand which hosts might be involved in traffic that matches these vulnerabilities. And again, there were some pretty good papers based on that, not so much at FloCon, but elsewhere. There have been some work. There has been quite a bit of work at looking at traffic that matches vulnerability exploration. And so there's a lot that's there. And again, we could script it, and I scripted it here. I'm not going to keep flashing scripts at you. I know that there's a lot of data, a lot of detail present here. Presumably when you get to proceedings, if you're interested, this is something that you could field out, or get in touch with me at the contact address that I'll get present at the end. But again, the idea is you're simply generating things out and producing inputs that could to feed into network defenses. Rather than display it yet again, we've used Jeff Janey's existence plots that he developed several years ago. The idea is to plot what the attack surface might look at dynamically, both incoming and outgoing, and looking at both what applications are supported, basically in terms of application labeling done by YAF, and also at what external addresses are involved. An existence plot is basically a two-dimensional heat map where the horizontal plot is time, in this case over the hour of the exercise, and the vertical axis is some characteristic of flow. In the case of the applications, it's the application labeling. In the case of the external addresses, it's the external address space plotted vertically. And the basic color of the plot, blue is below normal traffic that occurs below the first quartile. Blue is blue is below the first quartile. Yellow is between the first and the third quartile, and red is above the third quartile. So it basically gives you some idea. The reds are the hot spots. The blue is traffic present but cold, and basically the ones that don't have any traffic, there's no data displayed. It's a useful visualization because it not only tells you what traffic is present, but it gives you some idea of the distribution over time. And presented over time like this, you can get some overall feel for what the demands on the network are. This particular existence plot script uses Rayon, which is again software that we produced, and basically is generated, and the plot code is available if need be. The third approach is resistance, and this strategy is okay. We could not necessarily prevent the initial intrusion. Can we prevent or slow propagation or escalation of the intruder's activity within the network? And this gets a little bit more complex analytically. Ideally, what we want to be able to do is apply signatures across flows. And George Jones and I presented last year on a system to do flow-based signatures, or multi-source-based signatures, actually, correlating different data. But the idea here is to be able to tie together several different patterns of activity in the network and be able to cumulatively deal with that and be able to use that to spot attempts to propagate or exfiltrate data or attempts to escalate levels of privilege based on the changes in system behavior. DNS responses without prior requests, DNS responses coming from non-authoritative sources in a way that changes network behavior. Email or web contacts to addresses associated with DNS sources in some particular way. The other approach that can be done here is looking at anomaly analysis, look at residuals, particularly on stack time series analysis, look at departures from normal volumes on known services, look for unusual packet sizes or bytes per packet size, averages across normal services, and of course beacon detection, and spot the growth of beaconing on the network, because over time the hosts that are beaconing should be relatively stable. If we spot new hosts starting to beacon or beacon in different ways, then that can be an alert that we've got escalation or propagation and need to take more defensive action. And certainly blocking regularly occurring packets can be done. And again, we have an existence plot to illustrate this. This existence plot showed the DNS responses without requests plotted by the source of the DNS response. This one, unfortunately, was about the only one of the varying signatures that I listed that was present in the blue-red data. Again, it was an exercise, so they really didn't go too terribly deep. Once they were able to pop a host, they basically went ahead and propped it. They didn't do any self-propagating code. They didn't do any in-depth scripting within that data set. They didn't need to. Okay. And finally, analytics supporting recognition/recovery. There, the idea is, if we do have damage to the network, if we do have things, then let's find out what's damaged rather quickly. Prioritize the recovery efforts on things that will interfere with the attacker or block the flow of value out of our network. And most of the presentations that you've heard this week have basically fallen into this bucket. There's a lot of stuff here in terms of attack discovery, a lot of stuff here in terms of host monitoring, service monitoring, attack profiling, and data exfiltration detection. Certainly there's been a lot of previous speakers that have covered this that really deal quite well and quite effectively in this space. So, and it's true also that analytics can be shared across strategies. For example, beacon detection supports the last two. Network profiling supports both deception and recognition recovery. Many recognition recovery analytics may also be able to support frustration if you can apply them close enough to real time. The analytics also support other analytics. Certainly network profiling will support attack surface estimation, and that estimation in turn will support vulnerability estimation by focusing our attention on specific vulnerabilities. Certainly a lot of surface monitoring supports beacon and exfiltration recognition. So the idea is a well-planned defense will use multiple strategies. These are not alternatives. These are simply options that are available to you, and you can pick from them in a Chinese menu type of manner to try and improve things in this regard. Certainly the stacked analytics give you an opportunity to use a probably overused buzzword, defense in depth. And the idea is that generally you want to put your effort at deception and frustration first, largely because these tend to be more static mechanisms and they tend to involve less damage to the network than if we have to put our focus of effort in resistance, recognition, or recovery. In particular, recognition and recovery are going to be expensive because there the damage has already occurred. And so not only are we putting the staff time in to apply them, but we're also having to deal with downstream or cross-stream effects on dealing with them. Sean Butler, several years ago in her PhD thesis, outlined the spider diagram, and the goal here is to have security goals and be able to tag in what approaches you're taking to support each security goal. So authenticity on the login server and things like that might be an example of security goal. And the idea is by presenting an overall map, you've got some idea of where your defenses are in fact effectively layered, or where you've got pure redundancy, and also which strategies you're overusing. And coming up with an understanding of what overuse is present can help guide your overall defensive effort. So network flow analysis is historically is associated with either network engineering or incident response. Those were probably the initial thrusts that led to a lot of the network flow activity. But there's a lot of other applications that are productive. And we need to start thinking not just how do we do better attack detection, how do we do better approaches, but also what ways can we use it that are not as focused specifically around the idea of incident response. New analytics are being formulated, new capabilities exist for doing that. I realize I'm a little bit early, but I'll give the favor of a little bit of time both to the chair, the session chair, and to the other speakers. In the meantime, however, are there any questions? Go for it, John.
So obviously a lot of this is situational awareness. How much of this do you think applies to learning what attacks the adversaries are making, so some sort of like threat awareness?
Certainly for the frustration or resistance approaches, there's a lot of attack awareness stuff in there. The deception is really more geared towards mimicking. So that's kind of attack agnostic. So it would not be quite as much focus there. Okay, thank you.